Okay, welcome to the very last R Lab 3.4. In this video, I'm going to talk about the split, apply, and combine concept using the summarize and the group by functions in R. Um, so uh, Group by and summarize are really handy. In all the labs that we've done so far, the forestry lab, the wildlife labs, we've taken data sets like the forestry data, we took each plot and we grouped by those plots and then summarized them. And we used pivot tables to do that. In Access, we used queries to query certain criteria and basically group by species or other variables, and then summarize across those different levels within a variable. So we're going to do that same thing in R, but as you'll see, of course, R is superior because we can track those steps step by step. We can go back and tweak them. We can share them with our friends in a really easy language. Well, not so easy, but it'll get easier through time, I promise. Okay, so the way this works is the group by function. The first argument in group by is tell me the column or the variable that you want to split things apart by, right? So if we group by taxa, then we would split out birds, reptiles, mammals, and rodents, or what was the other one? Birds, reptiles, mammals, and amphibians. Um, anyway, it will split those out. Um, and and then we use the summarize to say to what do we want to know across each row then. So each row represents a whole group within that variable or a whole level, and then we summarize it, we collapse it to know what's the mean, what's the minimum, the maximum, and other statistics. So let's see how this works. Before we do this, I just want to review the mean function. So as you'll recall, mean is this cool function in the base R package where we can calculate the mean of anything. So if we do surveys, $weight, um, if we go to run this, this isn't going to work, okay? When I run it, well, it works, but it spits out an NA. And that's because the base package, and if we come over here to the help and we type in mean, it's going to bring up this information, right? And I can look at the different arguments. And one of those arguments is NARM. If I copy that and I throw that argument in up here, and then I say or NARM equals true, and you can read more about that in the help over here. But basically what that's doing is it's removing all the NAs from that weight column and then calculating the mean. Basically, this is a backstop where R is saying, I'm not going to calculate the mean unless you tell me what to do with these missing values. Do I treat them as zeros, or do I just calculate the mean without them? So it's forcing the scientists to kind of think through what they're doing, right? So this is the mean of that entire data set, right? Okay, so what we want to do is summarize over all these different groupings. Now, the way we did this in the past, we used the summary function, right, to do, um, we could summarize over surveys, and it would tell us something about every one of the categories, right? It'll tell us the summary statistics for the entire column, but it won't tell us the summary statistics for each level within that column. So that's what we're about to do using this group by function. Okay, so if we want to calculate the mean weight of all the surveys, um, we could do this with the group by function and a pipe. So if we do surveys and then control pipe, and then we put in group by, and we don't put anything in there. So we're saying group by, but we're not telling it anything to group by. This is essentially the same as this up here. Is it saying group, and then we're gonna throw this down here. We're gonna say that we want to summarize this variable. That we want to know what's the mean of survey weight, right? And I need to add another ending parentheses because this is nested within that summarize function, right? Okay, so when I run this, it ought to give me, if I've done everything right, it gives me 42.7. So that it's calculating the same 42.67, so it's calculating it a little bit differently, but it's pretty darn close. I'm not sure where there's some kind of rounding error or something going on. Okay, so basically I've figured out I can make this work with the group by, but basically I left that group by function empty. So to see how this really works, we're gonna tell it what we want to split out. So let's use something that's only got 3 levels in our surveys data set. So the most simple variable I think is the sex variable, right? So sex only has 3 levels: male, female, um, and blank, right? So if we do that, then here down in our output, we can see that are grouped by male, female, and not and missing value, and it's told us what the mean value is across each of those categories. But actually, it didn't. It gave us we forgot to do a critical thing. So we need to tell it a variable. We need to create a column for it to calculate in. So that's where I'm going to create this mean weight variable. So this is essentially the same as up here if I were to create an object called mean weight. It'll appear in our global environment, right? So here's the mean weight up here, and actually it is the same now that I'm doing it as an object. Okay, so it wasn't a rounding error in the console. Okay, so I need to create a variable to to print in the summary, right? So that's where down here I added in, so I'm saying summarize, create this new variable called mean weight, and tell me the mean weight of each level in the sex column. So now I do have mean weight right here, and 42.7 is the mean weight of each of those. I just find that hard to believe. There's a reason it was not working. I had that surveys weight in there. So I don't need to tell it it's the surveys data set. I tell that at the front, right? So I'm grouping by sex. I'm creating this new variable. So if I run this now, it tells me the correct. So the mean weight of the missing values was 64.7, the mean weight of females and the mean weight of males down here. Now the cool thing is that I can add another variable. So I can group by sex as well as something like species ID. So now it's going to split things out by sex, and then within sex, it'll split things out by those other categories, species ID. So now you can see that it just printed the first 10 rows, and there's 82 more rows. Now I'm getting the mean weight is NaN, and basically that means that there are some combinations where there are no variables and it will not calculate the mean. So it's telling me that there are no values to calculate. If we look at the tail of this, oh, I got to put in the pipe. So if we look at just the tail, then I can see, okay, at the very bottom, the last 6 rows, I've got all males and I've got all these different species and there's all their different weights. So at the head, at the very top, we were getting uh, NAs because there weren't values. Or remember, we got a whole bunch of species in this data set. I can't remember how many, but something like 30 or 40 different. Now, of course, in R, there's a million different ways we can do things. Now, I'm removing the NAs down here, but I could do that like we did before. I could do it up front using filter. So I could filter, and remember it's the pound sign is dot NA is the argument or is the function, and then whatever's in there, it's going to say, give me all the things that are not NAs. So if I put that up front, then I actually don't, it's a little bit tidier. I don't have to deal with this argument in the mean function. So let's see what that does. Let's see, it prints the same number of rows, and you know what I forgot to do? It gave me this weird output. It's because I didn't pipe it. So if I put in my pipe operator, I hit run. Okay, that's what I was expecting. So now I've got same thing. I've got all these values, and now if I print the head, it is probably going to be all values because I've already removed all the NAs. So by putting this up front, my output is a lot cleaner because I basically said, I want to calculate the means of all these species by sex. Uh, so first things first, let's get rid of all the NAs if I acknowledge that I'm going to treat those as just missing values. Okay. So maybe I want to print more than just the first 6 rows or the last 6 rows. I can specify the number of rows I want to print. Instead of using head or tail, I can use this print function, and I can just tell it how many rows I want to print. So maybe I want to print 15 rows, the first 15 rows of data. If I do that, then here it'll tell me there's the first 15 rows and there's 49 more rows there, right? So I could print all 49 rows by setting that to 49. Or maybe I want to create a new object, which I can do with the assignment operator. Um, maybe I want to calculate the minimum weight, and I can do that kind of by just adding in another argument in this summarize function. So if now another trick with R is that anytime you put in a comma and then hit enter, it takes you down to the next row. As long as the row ends in a comma, it will continue reading the code, just like another argument. So comma means go to the next line, as well as the next argument. So here I want to put in maybe minimum weight, and I'll say that that's going to be equal to min is another argument or another function in the base package. And let's see here. I don't need another pipe because I've got that comma. So essentially this is the same as just leaving this on one line like that. Like this is all that open and ending parentheses is all one. This is the function summarized. This is the first argument. There's a comma and there's the second argument and there's the ending parentheses that closes the entire function. So I don't need to put another pipe operator. I like to put those below each other because I'm saying summarize and I'm saying there's a couple of variables and I could keep adding variables. I could add maximum, I could add median, mode, all kinds of things. I could add some other function. So if I do that, and let's just print uh, 8 rows, okay? Um, so now the output is kind of getting cool. Now I've got the sex, and at the head, I've just got um, those missing values, right? I've got species ID and the mean weight and the minimum weight for that species when the sex was not determined. If I go down, I'll find that species again for male and female, and then I can start doing some cool tables and graphs and comparing those different categories of animals. I can use the arrange function to arrange the output um, in a certain order. So if I do arrange by minimum weight, this is going to give me the output, but you can see that the minimum weight here, it's starting at the minimum 4, and then it goes up to 5 and 6. So I'm organizing the output by some value that I've created. So that's a cool feature. Um, I can also use, well, I can make it descending by popping in, oh, this is getting a little crazy. I can use this descend function. So if I just nest that within a range, DESC, and then I have to put that closing parentheses. If I do this, it's going to take these and it'll put them in descending order, right? So now it's going to start with the minimum weight. It's going to start with the maximum minimum weight, and it's going to descend to the minimum weight by species and sex. And you can see over here, it's no longer sorted by sex. It's just going to the whichever combination of sex and species ID was the minimum. Um, okay, I can also, I can do other things just with the count function. Um, so maybe I just want to know the number of observations, male, female, and missing. I can do that really simply with the count function. I can also, I can make count a little more complicated, and I can count by multiple um, variables. So I could count by sex and taxa, O-T-A-X-A. And if I do that, now I've got each combination of sex, male, female, and missing, plus taxa. And you can see out here in the output that there's some combinations that aren't in the data set, and those are just missing, right? There aren't any, it looks like there aren't any female or male birds or rabbits or reptiles. Now I'm guessing that's because this study is mostly focused on rodents, and so when they catch a bird or a reptile in one of those little Sherman traps, they're probably just not taking detailed data on it. Okay, and then this sort function also has arguments which you can look up. So one of the arguments in the count function is sort. And so if I set that to true, that will sort these automatically by the number of observations. And we can see that there were more male rodents, followed by female rodents, followed by rodents that didn't get sexed before they got away. Birds are the next most likely critter to get into those traps, followed by rabbits. Must be a pretty small rabbit, and reptiles. Um, so that's it for this session. I'm sorry this one was a little bit longer. This is the very last R Lab video. So let me know if you have questions. I'm in the Zoom room. There is this last exercise. So if you scroll down this challenge, you ought to be able to use pipes and these group by and summarize functions to answer these questions. So you should be able to find the mean, the max, and the min hindfoot length for each species. You can figure out what's the heaviest animal measured in each year. So if you group by year and then summarize the the max weight um, by species ID, you ought to be able to do that. So play around with this, and then you should be able to finish the exercise. Let me know if you have questions. Thanks.